What's going on, everybody? I thought I'd do a video on what I've done to help with the heating of our garage, which is attached to our house, but it doesn't actually have any heating vents in it, so we have to heat it with space heaters. And then we also have a window air conditioning unit over there. But in order to electricity, our whole house is electric, and it's one of the most expensive ways to heat your house is because electric is $1 in, $1 out. It's the most expensive way. Although diesel fuel, the current administration's changed to want everything to go electric. Electric's most expensive, but this is where we're at. And what I've done to make our heater more efficient out here in the garage is, instead of it just blowing into the air and then it just dissipates into the air, have the heat blow into another object, another metal object, to where it'll help absorb the heat and then it can radiate off of that. What I've done is, it's like a $15-$20 electric space heater. It's got an adjustable temperature range. I have it blowing onto an old radiator, electric radiator with the oil filled inside it. I have it blowing from there into that, so it's going through the vanes, and then I've got a cast aluminum skillet that's just sitting on top of that, just to help absorb more heat, and it's just blowing in line. And so it'll blow through there, the heat will come out through the end, but if heat rises, so being here at the bottom, it gives the opportunity to go up, heat this vintage stove that's probably from the early 1900s, which is all cast iron. So the heat's going to come up through here, heat up the stove, and just as air passes, it even comes out through the vents up the top. To give you an example of that, I have one of these digital thermometers with just a laser pointer, and just showing you what it, on this our stove that's right next to it, 71 degrees. 72. Now this is going to go right next to the heater, and it's at 75. I'll go into the heater, and you can stop, Lexi. I have a helper. So you can see it's 170 degrees coming out. Oops. And it's 100 degrees right there, heating up this element. Or not heating up the element, but heating up the cast aluminum. As you get further down here, obviously it's going to get cooler. And once again, directly above it, it's 77 degrees, 76, 80. I think it's because it probably comes out of there a little bit. Over here, 85, 85. And up here at the cooktop, the airspace in there, 87, 90. So even all the way here at this other end, still 90 degrees, when down there at that cast aluminum piece, it was 100 degrees. So that heat's going to transfer, the airflow is going to go up, the heat is rising, so it's heating all of this up here. Even at the top here, 90 degrees. So all this is nice and warm. It's going to radiate the heat. It makes that little heater, it heats all of this up the heater will stop when it reaches the temperature you have it set for. It'll stop. All this metal, it'll stop being heated, but it still takes time for it to cool down to the point where it'll keep putting out heat until it reaches room temperature. By then the heater will turn back on, but it transfers the heat into it, makes it a much more efficient. Before using the stove to help, I had it running directly through just the radiator heater with the other piece. But just to help save space, I put it under there, and it actually makes it more efficient. See how hot it is? Even Lexi's hot. And there's Maggie picking up a little mess over there where some cat food got knocked down. Where'd everybody else go? Alright. Anyway, I just thought I'd like to share all that information with you. And you can use your own version at your house. Most people aren't going to have a big cast iron stove around, but if you have some old radiator heaters or just some other metal objects that the fan can blow through, it'll make it more efficient.